So now let's talk about hyperconjugation. So what is hyperconjugation? Hyperconjugation is a phenomena in organic compound referring to delocalization of sigma electrons. Here it is a delocalization of sigma electrons. Sigma electrons are delocalized, okay, and it is also known as no-bond resonance, and it is also known as sigma pi conjugation. It is also known as no bond resonance. It is also known as sigma pi conjugation. Now let's talk about hyperconjugation. How many types of hyperconjugation we know? We know two types of hyperconjugation. One is plus H and another is minus H. One is plus H and another is minus H. So let's talk about first plus H hyperconjugation. So let's talk about plus H. Now when we talk about plus H hyperconjugation, let's take an example of the ethene carbocation. Ethane carbocation. So now here we see the carbon is attached with 3 hydrogen. This 1 hydrogen, this 2 hydrogen, and this 3 hydrogen. Now here one carbon, it has one empty p orbital attached with 2 hydrogen. This is empty p orbital. How it is empty p orbital? In chemical bonding you have seen that here it is the hybridization is sp2. When the hybridization is sp2, 1s and 2p are involved. These 3 are involved in hybridization, and this is left. The left one is known as pure p orbital. Okay, so here it is incomplete orbital. Okay, empty orbital, or we can say it is pure p. They are not pure orbital, they are now hybridized orbital. And now it is pure p orbital. Okay, now when this pure p orbital comes with in the directly contact with a sp3 hybridized carbon, this should be sp3 hybridized. What happens that this p gets overlapped with, okay, here the carbon, the hydrogen, this s bonding, it gets detached with carbon. Now here it takes the bond. Okay, when it takes the bond, it becomes H plus C. Now when it takes the bond, it is again forms a an H and H. It again forms a filled p orbital. This is a now filled p orbital comes directly contact with empty p orbital, and then it forms a carbon, double bond carbon, H, one H is above H. So again, if we see, this is a resonance again. Okay, but here what bonds are taking participation in resonance? Sigma. This is sigma bond and this is pi bond. That's why it is known as sigma pi conjugation. It is also known as sigma pi conjugation because here sigma bond has taken participation and pi is also taking participation. Okay, now here we have seen that all the resonance we have seen previously, there was a participation of only pi bond, but here it is also known as sigma resonance because the sigma bond is taking in participation, and it is also known as no bond resonance. No bond resonance means there is no bond present here. It is for a single time. It will be detached with that group. Okay. So if you see how many types of resonating structure we have, or we can't use the word resonance here. We will use the word hyperconjugation here. So we'll see how many types of hyperconjugation we have. So when it detached with that carbon, so how many hydrogen are there to be detached? 1, 2, 3. So 3 hyperconjugating structures are possible. 3 hyperconjugating structures are possible. Okay, so that's how we will see. Now what is the condition of hyperconjugation? Okay, now if we see here how many hyperconjugation structure we have, we have 3 hyperconjugating structures. So if we see more hyperconjugating structures, more movement of charge, more will be stability. So if you see more hyperconjugate structure, more charge, more will be stability. Now if we reconsider the structure again, CH3 CH2 plus. So the condition of hyperconjugation is that if we know that that the carbon next to the reference carbon is known as alpha carbon. Okay, now again beta, gamma, delta, that is Greek alphabet we use. Greek alphabet we use alpha carbon, beta carbon, gamma carbon, delta carbon. With the reference of main carbon we are considering, which have either in the functional group or some charge is there. Okay, cation and ion is there. So after that carbon we name the carbon alpha carbon, beta carbon, gamma carbon, delta carbon. Now the hydrogen attached with alpha carbon is known as alpha hydrogen. Okay, so condition for hyperconjugation is that alpha carbon should be sp3 hybridized. Alpha carbon should be sp3 hybridized. This is the condition for hyperconjugation. So now if we know that alpha, beta, gamma, delta, so we have to consider only alpha carbon that should be sp hybridized. And if more number of, now this is if we take more number of alpha hydrogen. Okay, so more number of alpha hydrogen, more hyperconjugating structure, more stability of charge. Okay, stability of charge means stability of compound. Okay, so and number of alpha hydrogen equals to number of no bond resonating structure, or we can also name it as a number of hyperconjugating structures. Number of alpha, number of resonance, and number of hyperconjugating structures. Okay. Now if we talk about the stability, now if we need to calculate number of no bond resonance, okay, hyperconjugating structure. So let's consider an structure. So if we want to know how many hyperconjugate structure we have, first of all we have to count number of alpha hydrogen. So 1 alpha carbon, 2 alpha carbon, 3 alpha carbon. So how many alpha carbon it has? This is alpha, this is alpha, this is beta, this is alpha, this is beta dash, and this is beta, this is gamma dash. So how many alpha carbon we have? That alpha carbon we have. Okay, so it alpha, it is how many here hydrogen we have? 2 here, 3, and here 1. So 2 plus 3 plus 1 equals to 6. 6 hyperconjugating structure we will be having here. Okay, so now again if we consider one more another example, say positive charge is in conjugation with CH3. Not conjugation, the structure is like CH3, CH3, and CH3. So we know that carbon positive and CH3, CH3, CH3 is there. So how many? 1, 2, and 3 alpha. 3 alpha carbon we have. 1 alpha carbon. How many? This is alpha, this is also alpha, this is also alpha. How many hydrogen we have? How many hydrogen? 9 alpha hydrogen we have. So 9 hyperconjugating structure we will be having. Now if we talk about the negative charge, suppose we have CH2 minus and CH3. Now could be there any hyperconjugation possible? Let's check whether hyperconjugation possible or not. Okay, so let's draw it again. C H and H. Now we know that where the carbon will shift here, hydrogen cannot take the charge because the electronegativity of carbon is more than that of hydrogen. So here carbon this cannot shift, so it is not possible. In carbon ion, the alpha in hydrocarbon carbon ion, there could be no bond resonance, so there can never be no bond resonance or hyperconjugation structure in case of hydrocarbon only. Okay, we have only carbon and hydrogen here.